When you hear nitrous oxide, you might think of laughing gas and the dentist from Seinfeld.
Cheryl, would you ready the nitrous oxide, please?
Or the last of the V8 interceptors from Mad Max the Road Warrior. But did you know that it's also the third most important greenhouse gas, just behind carbon dioxide and methane? And it's also a powerful ozone depleting substance? And that 75% of the nitrous in the atmosphere comes from agriculture. Much of the rest comes from combustion, so efforts to reduce CO2 emission will also reduce these sources of nitrous oxide. Since I'm going to be talking a lot about plants, I thought a floral print would be the way to go for this episode. First, just a little bit of chemistry. Our atmosphere is 78% nitrogen gas, or N2. At atmospheric pressure, it's biologically inert to humans. We breathe it in and out. It doesn't do us any good or any harm. It also isn't a greenhouse gas. To be honest, it's pretty boring in a good way. But nitrogen is a critical element for growing plants, which need it to make chlorophyll and amino acids. And while plants can get all the carbon and oxygen they need from the atmosphere, atmospheric nitrogen is too stable for plants to access directly. Before synthetic fertilizers were invented, plants accessed nitrogen via microbes in the soil and the roots of some plants, primarily legumes, which converted molecular nitrogen from the air to ammonia, or NH3. This is called nitrogen fixing. You can also add manure or compost, which contains ammonia. And then other microbes in the soil convert the ammonia to nitrate, NO3, which can be absorbed by plants. At least that's the ideal. If you want to maximize your crop yields, then you can add fertilizers that contain nitrogen. Today, that primarily means synthetic fertilizers, where the nitrogen comes from the process created by Fritz Haber in 1909. This process converts methane to hydrogen, which releases carbon dioxide, and then combines that with atmospheric nitrogen to make ammonia. Thanks to the Haber process, nitrogen fertilizer is now so cheap that there's no reason not to apply plenty of it. And it has been estimated that almost half the people on Earth are currently fed as a result of synthetic nitrogen fertilizer use. For this reason, Haber won the 1918 Nobel Prize in Chemistry. But that award was controversial since Fritz Haber had also come up with the idea of chemical weapons in World War I and oversaw the production and deployment of highly toxic chlorine gas released into enemy trenches. Ironically, the prizes were created by Alfred Nobel because of his disgust at the destruction his invention of TNT caused. The Haber process made the production of TNT and other explosives much easier. Haber knew this and was fine that his work supported the German war effort. He died in 1934 in exile on his way to Palestine after the rise of the Nazis. One thing you cannot call Fritz Haber is inconsequential. But I digress. If you look at a bag of fertilizer, you'll often see three numbers. That's the percentage of the fertilizer that is nitrogen, phosphorus, and potassium. I'm going to ignore phosphorus and potassium even though they're critical to agriculture. That's because they aren't important in the production of nitrous oxide. I'm also not going to talk about the myriad of micronutrients that plants need. The soil chemistry that supports plant growth is pretty complicated, but I'll do my best to stay out of the weeds and focus just on how we can reduce the emissions of nitrous oxide. To be clear, emissions of ammonia and nitric oxide are also happening and have their own negative effects, but they aren't significant greenhouse gases, so we won't focus on them. And when I use the term farmer, this includes backyard gardeners who tend to be less careful in their application of plant food. So the standard chain is a farmer applies urea, which is solid and convenient to deal with, or some kind of ammonia solution. The urea reacts with water in the soil to create ammonia and carbon dioxide. The ammonia then is processed by microbes in the soil, which can create nitrate, or NO3, which is what the plants want, or nitric oxide, or NO, which is not, or nitrous oxide, N2O, which is the worst. The application of synthetic nitrogen fertilizers account for the majority of nitrous emissions. So one way to reduce emissions is to reduce the amount of nitrogen-based fertilizer applied. But if not done intelligently, this will lead to reduced crop yields. So the key is to apply fertilizer efficiently. Two things can happen with the applied nitrogen. It can end up as nitrate and be absorbed by a plant, or something else that wastes the fertilizer and creates pollution. It might be ammonia that goes into the atmosphere or leaches into groundwater. It might be nitrate that goes into a lake and encourages algae growth. Or it might become nitrous and go into the atmosphere where it creates havoc. The nitrogen efficiency is the percentage of nitrogen that ends up in the target plants. You might have noticed that nitrate, what the plants want, has 3 times as much oxygen as nitrogen, while nitrous has half as much oxygen as nitrogen, a difference of a factor of 6. So you might not be surprised to learn that if there isn't a lot of oxygen in the soil, that it's anaerobic, that the microbes make more nitrous and less nitrate. After a heavy rainfall, the water replaces the air in the gaps in the soil, leading to anaerobic conditions and increased nitrous production. Heavy machinery or animals might compact the soil, reducing the microbes' access to oxygen, again leading to increased nitrous. Also, if the farmer applies too much fertilizer at one time, the microbes consume the available oxygen, making nitrate, and then they make nitric oxide and finally nitrous oxide as the oxygen content of the soil drops. There are no silver bullets to improve nitrogen efficiency and reduce pollution. What works in one climate may not work in another, but some practices do generally help. Apply as little synthetic nitrogen as possible is a guaranteed winner. Another is to have multiple applications of nitrogen that are timed with when the plants need food during times of heavy growth. If you're applying urea on the surface, either time it with a light rainfall or follow with irrigation. There's clear evidence that organic farming methodology does lead to reduced pollution, in part because the nitrogen becomes available over time, not all at once, so anaerobic conditions are less likely to occur. Slow-release synthetic fertilizers have a similar benefit. Even if going fully organic doesn't make sense, some organic practices like clover as a cover crop and applying less synthetic fertilizer might. Field sensors measuring nitrogen concentration, humidity, and temperature can provide a path to optimize nitrogen management and reduce pollution, while increasing yield by providing actionable data that improves nitrogen efficiency and reduces nitrous emissions. Part of the problem is that the pollution is an externality. The farmers who control how and when to fertilize is not paying the cost for their decisions. We all are. These best practices may be more expensive, but they don't significantly reduce the farmer's cost or improve yield. So there's little financial incentive to do the right thing. And since the right approach would vary from field to field, it's difficult to even know what best practice is, much less how to mandate it. I know I learned a lot making this video. I think it's because city people like myself and almost everyone else in the developed world are so far from the farm that we have no idea what the challenges are. And maybe that's the takeaway. Farmers have a huge impact on the world. First, we'd starve without them. Also, they're responsible for 44% of the land in the US and 38% in the EU. and they're responsible for most of the emissions of the third most important greenhouse gas. So we need a solution, but if we screw it up, we'll die of starvation before the climate kills us. Since you made it to the end, you either learned something or are too stubborn to stop watching when I'm being confusing. Please like and subscribe if you learned something. If you want to support this channel financially, you can buy me a coffee. The link is below and right next to me. And you can watch another one of my videos here. Please share this video with anyone you know who is a backyard farmer who might not pay enough attention to their fertilizer applications.